Hello guys, again we are taking the topic integration by parts. In this video, we will discuss the integration of inverse trigonometric functions using substitution and by parts method both. In the question of inverse trigonometric function means how to integrate these. So in this question, first we will use substitution because the given function will not be in a standard form, that will be in modified form. So first we assume that extra part in terms of theta or t, by which we can change its this expression into a standard form. So first we will try to substitute to make the given expression into standard form. Now after this substitution we will get the standard form, but this standard form will be in terms of theta or you can say t. Right now we have the product of two functions, and as we know, for the multiplication we have two functions in multiplication, then we will use by parts method or you can say UV method. Right. So after this integration we get a result in terms of theta. Now integration is easy after using by parts and making the given expression into a standard form. We can easily integrate that function and we get the result or you can say integration, but in terms of again theta or t. But we want to collect the answer in terms of x again, so we use the method substitution once again, and we substitute according to our assumption. We substitute the values of theta or kind of sine theta, inverses, and in terms of x again, then we get this result in terms of x. So this is the whole scenario which will be used by us for the integration of trigonometric functions. So on the basis of this working method we will integrate inverse trigonometric function. So we are taking a question inverse function like integrate tan inverse root x, and this is simple, and you can see this is not a standard function, this is not tan inverse x, so this is the modified function. Right now first we use substitution. Let root x equals to tan theta, or you can say x equals to tan square theta, and when we differentiate this we get 1 over 2 root x dx, and this is x square theta d theta, and we will collect the value of dx. So it is 2 root x x square theta d theta, and we can place the value of, so dx is 2 tan theta and x square theta d theta. So right now we substitute these values and we have dx is this. So first step, we want to convert the given function into standard form. So it becomes tan inverse, the value of root x is tan theta, and dx equals to 2 tan theta sec square theta d theta. And right now tan inverse or tan, these will be neutralized, you get theta only, and 2 comes out, 2 tan theta and sec square theta. So right now we have this expression, and this is algebraic function and this is trigo function. So it is the first part and this is the second part. Because we want to apply step 2 by parts method, so there should be the product of two functions, so algebraic and trigonometric. According to Eilert, we order this. So this is theta is just like algebraic function, and this is tan theta and sec square theta is trigonometric. So algebraic function has higher priority, so it will be first and it will be second. Now we use by parts method, but before it, first we integrate this. So we have second part as tan theta and sec square theta. So first we will integrate this. We will collect the value of its integration. Then we consider tan theta as u. So it is u, and on differentiation we get this is sec square theta, d theta and du. So we can substitute this value as du. Right now we have integration of this is u square by 2, or you can say u is tan theta, so tan square theta by 2 plus c. So this is the integration of tan theta, sec square theta, d theta. So we can substitute this integration as tan square theta by 2. But our question is 2 theta, tan theta, sec square theta and d theta. So we will use by parts right now. On applying the by parts rule, first function as it is, we integrate the second part, that is tan theta sec square theta. We differentiate the first part and integrate second part, tan theta sec square theta, and finally once again we integrate it. So it is theta, and the integration of this part, as we have collected this value, it is tan square theta by 2. So we place the value tan square theta by 2 minus the differentiation of theta is 1, and the again integration of tan theta sec square theta means this part is tan square theta by 2. So it will be cancelled out. We get theta tan square theta, and this is 2 or 2, it will be cancelled, and we have tan square theta. Now for the integration of this, we convert into sec square theta minus 1 d theta. Now it is theta tan square theta minus sec square theta minus 1. So it is minus sec square theta d theta plus d theta. So right now we have this value, and the integration of sec square theta is tan theta, and it is theta plus c. So according to our assumption, our first substitution, we have the value root x as tan theta. So x is tan square theta. Means when we substitute this value, and theta will be tan inverse root x. So we substitute these values. So theta is tan inverse root x, and the value of tan square theta is x, minus tan theta is again under root x, and theta is tan inverse root x. So in these two parts we will take tan inverse root x as common. So we get x plus 1 minus root x plus c. So this is the answer in terms of x. So first we use substitution and make the function standard. Second, we use by parts and integrate that standard function, and finally once again substitution to get the final result in terms of x. Integrate cos inverse of 1 minus x square over 1 plus x square dx. So again we use substitution. Let x equals to tan theta. So dx equals to, we get sec square theta d theta. Now we put these values in given expression. So it is cos inverse of 1 minus tan square theta over 1 plus tan square theta, and the value of dx is sec square theta d theta. And according to trigonometric formula, we have formula cos 2 theta equals to 1 minus tan square theta over 1 plus tan square theta. So we substitute this value, cos inverse cos 2 theta, and this is sec square theta d theta. So these will be neutralized and we get 2 theta sec square theta. Right now we have theta and sec square theta. Now we have two function in terms of theta in product. So we will use multiplication method, means we apply by parts. So first we use substitution, and right now we are using by parts. So it is the first function according to Eilert, and this is trigonometric function. This is algebraic and this is trigonometric. When we use Eilert and order these two functions, so algebraic function has higher priority, so it will be on first position. Now we use the formula, multiplication formula or by parts. So we have 2 outside the integration. So it is theta sec square theta d theta. Right now we will apply the method. So it is twice of theta as it is first function, integration of second function minus differentiation of first function integration of second function, and whatever the product of these two we integrate once again. And right now this is twice theta as it is, integration of sec square theta, this is tan theta, minus differentiation of this is 1 and it is tan theta. So it is 2 theta tan theta, and the integration of tan theta is minus log of cos theta. So we put this minus log of cos theta. So we have twice theta tan theta plus log of cos theta, and right now the integration of given question is done, but this is in terms of theta and we want to collect the answer in terms of x. So we use substitution once again, and our assumption was x is tan theta, and according to this we can place 1, and if it is theta then it is perpendicular over base, so x over 1, so it will be 1 minus 1 plus x square. So we want the values of theta will be tan inverse x, so it is tan inverse x, and tan theta is x plus log of cos theta, and according to cos is 1 over this, so it is 1 over under root 1 plus x square. Right now we can place it as using log theorem, it is minus log of under root 1 plus x square. We can change the sign and reciprocate this, plus c, this is the answer. So right now our answer is in terms of x.